John Dalton and the atomic theory. John Dalton was an English mathematician and chemist. While doing his work as a chemist, he worked with pressure and gases. He released his work on pressure and gases in a series of papers entitled Experimental Essays, in which he published the law of partial pressure, also known as Dalton's law. This law stated that in a mixture of ideal gases, each gas had a partial pressure, which is the pressure that the gas would have occupied if flown in the volume. This can be represented by the formula Pt is equal to P1 plus P2 plus P3. This had an important impact upon chemistry, although it was second to his most important work, the atomic theory. Dalton was a man who came up with the idea of atoms making up elements, which was assisted by decades of suggestions from the works of other chemists. This idea came to him while he was working with another series of laws, the laws of multiple proportions. The theory was the result of his experimentation on the composition of compounds, which he believed to be the ratio of round numbers, but he did not know what the ratio was composed of. This led him to wonder what the base of their scales were. The idea of compound structure by much smaller atoms arose in his mind as a purely physical concept, which was forced upon him by his studies of the physical properties of the atmosphere and other gases. He published his idea in his paper on the absorption of gases. To promote this, he questioned, why does not water emit its bulk of every kind of gas alike? This question I have duly considered, and though I am not able to satisfy myself completely, I am nearly persuaded that the circumstance depends on the weight and number of ultimate particles of the several gases. The ancient Greeks, whose philosophers talked about atoms, proposed the idea of these particles much earlier. He proceeded to write down the first table of atomic weights, but soon it appeared that he was confronted with the problem of calculating the relative diameter of these particles called atoms, which he convinced all gases were made of. Because he assumed the combination always takes place in the simplest ways, he came up with the idea that chemical combinations take place between particles of different weights. This was an important idea, because it set his new theory separate from the speculation of the Greeks. Because of his early ideas in elemental combining in the simplest ways, he listed compounds as binary, ternary, and so forth, which depended on the number of atoms a compound had in its simplest empirical form. He started to use his own symbols to visually represent the atomic structure of the compounds, comprised of circles and lines. He took his ideas and ideas from other chemists to combine what he is most famous for, the universal atomic theory. His theory is composed of 5 main ideas. Dalton's first idea: all elements are made of microscopic particles called atoms. Dalton's second idea: all atoms of a given particle are identical. Dalton's third idea: the atoms of a given element are different from those of any other element. Dalton's fourth idea: atoms of one element can combine with atoms of other elements to form compounds. A given compound always has the same relative number of atoms. Dalton's fifth and final idea: atoms cannot be created, divided into smaller parts, nor destroyed in any chemical process. A chemical reaction simply changes the way atoms are grouped together. Dalton added an additional statement that prevented his theory from being accepted for many years. The add-on was, when atoms combine in only one ratio, it must be presumed to be a binary one, unless some cause appears to the contrast. Dalton had no evidence to support this statement from his work and theory, and it caused him to wrongly assume the formula for water was OH, not H2O. All but 2 of his ideas are still believed today by scientists. An atom has been proven to be able to be subdivided, created, or destroyed by means of nuclear fission, fusion, and atom smashing. Also, atoms of the same element are not all identical, because different isotopes for some elements exist. Dalton started the work on gaining knowledge about particles known as atoms, and helped shape chemistry into what it is today.